Hello everyone, welcome back to Analog Snippets. We will continue to discuss analog interview questions, and today's topic is current mirrors. Current mirrors are treasure trove of analog questions. They are obviously fundamental building blocks of any analog design, and all experienced analog engineers are expected to have a very good grasp of current mirrors. So doing well on current mirror questions is of vital importance. So in this short video, I'm going to discuss some common questions and some not so common questions that were asked on the topic of current mirrors in the interviews that I was part of. So let's start by drawing a simple NMOS current mirror. So you can be asked the valid output range of this current mirror. For example, you can be asked if output is increased from 0 to some high voltage, what would be the plot of I out? And most people answer it without any problem. Another common question is sources of error in I out. Here you are expected to talk about systematic errors and random errors. You may also talk about the errors caused by noise and PSR. And this question often leads to the next question, how do you minimize these errors? Let's first focus on the error caused by random variations or mismatch. So the most common question is how to size these devices to minimize the mismatch. And about 60% people get it right. The most common mistake people make is to say they need to increase area. Now, the area can be increased by either increasing the width or length or both. And the thing is, they do not give you the same result even for the same area increase. So here I ask this question. Let's suppose we have choice of these three W and L for the given device. Of course, all have the same area. So which one will have the best matching? So looking at these values, most people can point out to the right answer, but they are not sure quite why. So make sure that you understand the matching in the current mirrors. This matching question can also be framed in terms of region of operations of these devices. Desired GM over ID is another way to ask this matching question. Discussions on systematic error lead to the topic of cascode current mirrors. So some common questions are, what is the absolute minimum V out that we need here? How to optimize the bias for this MCAS transistor? What is the impact of this MCAS on the noise and the matching of the output current? What is the R out seen from the V out? One of the questions that I explore is, let's say in worst case, either MCAS or M2 or both go into the linear region. What is the overall impact of that situation? Some people also like to ask about gain boosting and register degeneration topologies. Discussion on output noise is also becoming a common question in current mirror topic. So basically types of noise and how you reduce each of them. I've seen at least one person asking about the frequency response of current mirror. So basically Bode plot of output current if you start increasing the frequency of input current. Alright, so these are some common questions. Let's now look at some not so common questions. Let's consider this circuit. This is pretty similar to a simple current mirror, except we have added a resistor on the source of the output transistor of this mirror. And let's say there is 1:2 ratio between M1 and M2 W by L. So the question is, given the sufficient V out, plot the I out if I in is increased from 0 to some high value. So basically transfer function of I out versus I in. And we have spent a lot of time discussing this very circuit and this very question. In my head actually it's a simple question, but surprisingly a lot of people struggle with this question. Actually here what we are looking for is a very generic broad brush type of answer. For example, how it would behave at very low current and how it will behave at very high current and how these two plots basically merge. So think about it and post your answers in the comments, and if I get sufficient interest, probably I'll make a video on this question. Okay, let's look at the next one. This circuit again has two transistors and one resistor, but resistor is now placed on the gate of the input transistor. Gate of the output transistor is connected to the other end of the resistor. And question is again the same. Given the sufficient V out here, plot the output current as input current is increased from 0 to a very high value. Another related question is having the same topology, but gate of M1 and M2 are now shorted together. something like this. Another question is to explain the working of this topology. Does this circuit work? How does it work? Are there any advantages, any disadvantages, and so on? And finally, there are questions on best design and layout practices in current mirrors. So basically things like keep the same unit devices, common centroid, dummy devices, etc. Here is one question that I ask. How will you do common centroid for a mirror ratio of say 1:3? So many people talk about using a dummy device, something like this, and which is actually okay. But what I am looking for is actually a perfect common centroid. And I know it's a trick question, but let me know what you think. Okay, to conclude this video, current mirrors are non-negotiables of analog interviews. So you have to do well in this topic. But the good news is that it's relatively simpler topic as compared to the other analog topics. We will continue to discuss analog circuit interview questions in the next video. So post your comments below and thanks for watching.